Hi, I'm Jasmine. Welcome back to the tutorial. In this part, we'll go over the reference method of finding functions in Geometry Dash. This method involves front references and back references to functions via other functions and virtual function tables. I modified my project a bit, but don't worry about it right now. We're going to start off with geometrydash.exe, libcocos2dcpp.so, A arch6464 CPU 0x0, x8664 CPU 0x3, and geometry jump. We are also going to edit our bindings here. So let's go to bindings, 2.2074, and geometry dash.bro. To start off, we will open this go-to menu by pressing the G key. Then we will go to our first example, EditorUI closeLiveColorSelect. As you can see here, there are 5 back references here. And of these, we're going to choose editColor. Editor footnote, be sure to check the function has the bindings on the platform you are looking for. Otherwise, you're going to have to find that function using the process I'll explain in this video. We're going to deduce the location of this function by using EditorUI editColor. And so once we go back to the Windows binary and type EditorUI editColor, you will see that this is roughly the exact same placement with a bonus function, closeLiveHSVSelect. And so we would note these in our bindings. Be sure to check if the function body matches, so that when we go to closeLiveColorSelect right here, it roughly matches. Now that that's out of the way, we can repeat the process for the ARM-based macOS binary. So let's go to EditorUI editColor. However, there is a problem here. The functions don't match. In fact, if you go back to Android here, you'll see it roughly matches the inside of the function. This is a phenomenon called inline expansion, and just about every compiler has it enabled by default. If you get this on Windows or iOS, you're out of luck and you have to recreate the function. However, if you get this on macOS, then we have an option here. We can use the back references to this function to find the function we're looking for. So let's go to this function. We're going to look at each back reference. No. Yep, that's it. We can also repeat this process for our bonus function here. So, no. Okay. You can also repeat this process for Intel-based macOS as well. Go over here. Go over here. However, in this case, if you try this on iOS, well, you'll find yourself out of luck. On both functions, so you're going to have to recreate it there. But I'm not going to go through that in this tutorial series. You can also use this process to find create functions, front referenced by scene functions, and back referenced by init functions. There are multiple scenarios you can encounter with these types of functions. One where both the scene and the create are inlined. One where only the scene is inlined. One where only the create is inlined. And one where neither are inlined. There are also scenarios where the constructor is not inline, ones in which you have to use back references to find the create function. Make sure you know which ones are which. Scene functions begin with Cocos 2D CC Scene Create. Create functions begin with operator new. And constructors begin with, well, another constructor. Our next example will be secret layer for create. If we go to the go-to menu, we type secret layer for vftable, or just vtable on our Windows. Click on a vtable, click on a virtual function table, and then you click this, one of the references. Not this one, not the destructor. Be careful about this one, not the destructor with the tilde, but this. As you can clearly see, both the scene, the create, and the constructor are inline, so can't use that here. So let's move on to ARM-based macOS. We'll type secret layer for vtable. And then we have a vtable. You can go through each of these references if you want, but like I prefer to, not mess with these too much. But like I could go to the first or last or whatever. You could go through each reference until you reach the create or the scene or whatever. But there are some times where the create won't be referenced at all. So you'd have to go through this init to find the scene function as well. But in this case, it is here. So we can note these here. And then we'll repeat the process for Intel-based macOS. However, if you look at iOS, you'll see the constructor is not inline. So you have to look at the reference to the constructor here to get to the create method right here and the scene right here. So now that we're done, let's save our bindings, and I'll be back with you in a moment. That's all for the reference method. The next part will focus on the string method, another widely used method for finding functions in Geometry Dash. And in any case, that's all I have for you today. If you have any questions or comments about this, please put them below. And if you like this video and would like to see more like it, please subscribe. And as always, have a nice day. Thank you.